In Episode 2, titled How CompTIA DataX Questions Are Built and What They Reward, the core idea is that this exam rewards judgment at least as much as it rewards memorization. CompTIA, which is the Computing Technology Industry Association, generally designs questions to measure whether you can apply knowledge in realistic conditions rather than simply repeat definitions. DataX leans into that philosophy by presenting you with information that is sufficient but not perfect, and then asking you to choose what makes the most sense given the goal and the limits. You will still need vocabulary and core concepts, but the scoring advantage often comes from recognizing what the question is trying to measure and selecting the option that fits that measurement. Once you see that pattern, the exam starts to feel less like a trivia contest and more like a structured series of professional decisions. Before we continue, a quick note. This audio course is a companion to the DataX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at Cyber.Author.me in the Bare Metal Study Guide series. Most DataX questions have a recognizable anatomy, and learning to spot it quickly can save both time and mental energy. A typical question begins with a scenario that supplies context, such as who is asking, what environment you are in, what kind of data is involved, and what outcome is expected. After the scenario, you usually get the task, which is the specific thing the question wants you to do, even if the wording is indirect or wrapped in polite professional language. Finally, there are constraints, which are the limits that quietly decide which options are valid, such as time pressure, regulatory boundaries, data sensitivity, licensing, budget, or availability. When you read questions with that anatomy in mind, you stop treating every sentence as equal, and you start weighting the information that actually drives the correct answer. Command words are the steering wheel of the question, and you want to recognize them quickly because they tell you what kind of thinking is being rewarded. Words like choose and select are often asking for the best option among several plausible choices, which means you should look for alignment with the stated goal and constraints. Words like compare usually signal that two approaches are being contrasted, so the correct answer will emphasize meaningful differences rather than generic benefits. Words like calculate can appear even when the math is light, because the exam may be testing whether you know which value matters rather than whether you can do complex arithmetic. Words like justify often mean that reasoning matters, so the best option is the one that is defensible in a professional setting, not merely the one that sounds most advanced. Distractors are not random, and the ones that cause the most trouble tend to sound technical, confident, and vaguely impressive. A distractor often uses the right vocabulary, but applies it in a way that violates the stated goal, the constraints, or the realities of the data. For example, an option may be technically correct in general, but it may optimize the wrong thing, such as improving a metric that is not tied to the objective, or increasing complexity without reducing risk. Some distractors exploit the instinct to over-engineer, offering a sophisticated approach when the scenario clearly calls for a simpler, safer, or more immediate step. Other distractors exploit familiarity, sounding like a best practice you have heard before, even though it does not fit the specific conditions described. The skill you are developing is the ability to hear technical confidence and still ask, calmly, whether it actually satisfies what the question asks you to do. Domain weighting influences what appears most frequently, and it shapes the exam experience more than most learners expect. Exams are designed with blueprints that allocate attention across topic areas, and that means some types of questions show up often enough to form recognizable patterns. Even without memorizing a blueprint table,
you can still benefit from understanding that high-frequency domains tend to produce recurring scenario structures, recurring command words, and recurring distractor styles. In practice, that means you will repeatedly see questions that emphasize data quality, governance, interpretation, and risk-aware handling of information, because those are foundational to trustworthy outcomes. When a domain carries more weight, the exam not only asks more questions about it, but it also uses it as the backdrop for questions that appear to be about something else. A useful mindset is to expect that the most common topics will quietly reappear inside many scenarios, even when they are not named directly. A practical way to handle this is to map each prompt to a domain first, and only then map it to the technique or concept that produces the best answer. If a scenario emphasizes who is allowed to see information, how long it can be kept, or what obligations apply, your domain signal is governance and compliance rather than pure analysis. If a scenario emphasizes messy inputs, missing values, inconsistent formats, or uncertain lineage, your domain signal leans toward data quality and preparation rather than model selection. If a scenario emphasizes communicating results, choosing the right metric, or interpreting outcomes for stakeholders, your domain signal is interpretation and decision support. Once you identify the domain, the field of plausible answers becomes smaller, and distractors start to lose their power because you are evaluating them against the correct category of problem. That is exactly what skilled test takers do, and it is also what skilled professionals do under pressure, even if they do not use the word domain in daily conversation.
There are also times when the exam is testing process rather than model math details, and recognizing that shift can prevent wasted effort. DataX questions may mention models, features, or evaluation terms, but the real question is often about the sequence of steps that makes analysis trustworthy. In those cases, the correct answer tends to emphasize validation, documentation, appropriate selection of methods, or alignment with the objective, rather than deep mathematical derivations. This is not a signal that math is unimportant in the real world, but it is a signal that the exam is focused on job-ready judgment and reliable workflow. Many learners stumble because they assume every mention of a model implies a math-heavy question, and then they overthink the wrong layer. When you notice that the scenario is emphasizing accountability, repeatability, or decision impact, you should expect a process-oriented answer, even if the vocabulary sounds technical.
Another major shift happens when compliance, privacy, or licensing appears, because those constraints can override what would otherwise be the best technical choice. Privacy language often signals that you must consider minimization, appropriate access, and handling rules before you consider optimization or convenience. Compliance references often mean that documentation, retention, auditability, and approved methods matter more than a clever shortcut. Licensing constraints can affect what tools or data sources are allowable, which can flip the correct answer from an ideal technique to a permitted technique. In these scenarios, a common trap is choosing an option that would be great in an unconstrained environment, but is clearly disallowed or risky under the stated conditions. The exam rewards the mindset that treats governance and constraints as first-class requirements, not as afterthoughts you handle once the real work is done. Elimination is one of the most reliable strategies in multiple-choice exams, and it works especially well here because many wrong answers violate data type realities. Data type realities include whether the information is structured or unstructured, whether it is categorical or continuous, whether it is sensitive, whether it is complete, and whether it can support the claims being made. If an option assumes a kind of data you do not have, ignores missingness, assumes perfect labels, or relies on attributes the scenario never provided, it is often wrong even if the approach is valid in theory.
Similarly, if an option treats highly sensitive data as casually shareable or suggests a step that would expose information unnecessarily, it tends to violate the scenario's implied obligations.
Elimination becomes powerful when you treat the scenario as a set of constraints that options must satisfy, because the wrong choices often fail a basic reality check long before you need to debate fine technical details.
Second-pass logic matters because not every question should be fought in the moment, especially when the exam is designed to manage your time and attention. Some questions are instantly clear because the scenario and the command word line up cleanly with a familiar pattern, and those are opportunities to bank time. Other questions feel ambiguous on the first read because multiple options sound close, or because a subtle constraint is easy to miss. A disciplined second pass works by revisiting those flagged items with a fresh perspective after you have cleared easier questions and calmed your mental noise. Often, the correct answer becomes clearer because you notice a single phrase you skimmed, or because your brain has had time to integrate the scenario without the pressure of immediate decision. This is not about changing answers randomly, but about giving your best reasoning the right conditions to surface.
Performance-based items deserve special attention because they are multi-step decisions, but they are not coding tasks, and misunderstanding that can create unnecessary anxiety.
These items usually present a structured problem where you must choose a sequence, match elements, or apply a workflow, often with a clear objective and a set of constraints. The skill being measured is whether you can navigate a realistic decision path, not whether you can write scripts or implement a full technical environment from scratch. In many cases, performance-based items reward the same judgment the multiple-choice questions reward, just expressed in a different format. If you approach them as, what is the professional sequence that reduces uncertainty and aligns with the goal, they become manageable. If you approach them as a surprise programming challenge, they become intimidating for no good reason.
Speed is not built by rushing, but by recognizing common pairings, such as a metric linked to an objective, and then selecting the answer that respects that pairing. In professional analytics work, you know that metrics are not universally good or bad, but are good or bad relative to the decision being made. The exam uses that reality by pairing objectives like reducing false alarms, improving detection, increasing retention, or ensuring fairness with metrics that either support or distort those goals. When you see a pairing, you should ask whether the metric actually measures what the objective claims to value, and whether it fits the data and constraints described. Distractors often offer metrics that look familiar but do not align with the objective, which is why understanding the pairing matters more than memorizing a definition. Over time, your speed increases because you stop evaluating every option from scratch and start recognizing recurring patterns of goal plus metric equals correct direction. Before selecting an option, it helps to apply a short mental checklist that feels like a single flow rather than a formal list, because the exam rewards consistency. A reliable internal rhythm is to identify the objective first, then confirm the constraint that matters most, then validate the data reality that limits what is possible, and then choose the smallest action or best method that satisfies all three. That rhythm prevents the most common errors, such as choosing something technically impressive that violates privacy, choosing something fast that ignores data quality, or choosing something accurate that fails the stated requirement. It also keeps you from being manipulated by distractors that are true in general but wrong in context. When your brain follows the same internal steps each time, you reduce decision fatigue, and your choices become more stable under timed pressure. The goal is not perfection, but dependable reasoning that repeatedly lands on the best answer.
To conclude Episode 2, it is useful to rehearse one question pattern and then explain your choice aloud, because that turns a vague sense of understanding into a concrete decision process you can repeat. A question pattern might be a short scenario with a stated objective, a clear constraint like privacy or time, and answer options that vary between correct alignment and tempting misalignment. When you practice explaining why your chosen answer fits the objective and respects the constraint, you are training the exact skill the exam rewards, which is selecting and defending the best option rather than merely recognizing a term.
This kind of rehearsal also reveals gaps, because if you cannot explain your choice cleanly, you may be relying on a hunch instead of a principle.
Carry that rehearsal mindset into the next episode, because the more often you can articulate your reasoning, the more confident and consistent you become when the clock is running.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.